Happy Wednesday, fourth graders. Before we launch in today's lesson, I want to give you today's review problem. Remember, for review problems like this, I want you to try it on your own, and I want you to return it to your teacher so that we can just see what you remember. If you forgot something, we can see what we need to teach over again. So the problem that I want you to try on your own and return to us is 463,895 minus 372,908. So try it on your own. Don't ask anybody how to do it, and then just do your best work. Do as much as you can. Even if you're not sure what to do, show us what you do know how to do or how you think you might solve it, and then return it so that we'll have a good idea of whether we need to reteach something to you. Okay, so that's our review problem for this lesson for today. Hello, fourth grade mathematicians. Today's math learning target is I can use models to add and subtract fractions and mixed numbers. Go ahead and say that with me. I can use models to add and subtract fractions and mixed numbers. So the first thing we really need to understand very well is what a fraction is. A fraction tells us how many parts of a whole we have. And we also need to understand what a whole is. A whole is the same thing as the number 1. So we can think of this model as one whole as the number 1. So look at the model. It's shaded in. It's a whole. It's a model of a whole. And it represents the number 1. It's one whole. We can also think of this model as one whole, the number 1. And just notice the only difference between the one we just saw and this one is that the other one was vertical, up and down, and this one is horizontal. It goes side to side. It's sideways. So what is a fraction? Well, again, a fraction is how many parts of a whole we have. So let's say our whole is broken up into 5 equal parts. That means that we have a denominator of 5 because we have a whole broken into 5 equal parts. And remember, a fraction is how many parts of a whole we have. So if we have 3 parts of that whole, then we have the fraction 3/5. And notice that the amount shaded in 3/5 is less than the amount shaded in the number 1 in one whole. So when we have a fraction like this, 3/5, that's less than one whole. It's how many parts of a whole we have. But a fraction doesn't always have to be less than one whole. Let me give you an example. Notice on the bottom left, I wrote the fraction 7/5. Now the first thing I want to notice when I'm thinking of 3/5 and then thinking of 7/5 is they both have denominators of 5, so they're both going to be wholes broken into 5 equal parts. With 3/5, I had 3 of those 5 equal parts, so we shaded in 3 of those 5 equal parts. But with 7/5, we're going to have a whole broken into 5 equal parts, but we're going to have 7 of those parts. So it's clear to me how we could shade in 3 parts of a whole broken into 5 equal parts, because there's plenty of space. But how do we shade in 7 parts of a whole that's broken into 5 equal parts? And the answer to that question is we have to draw a second whole broken into 5 equal parts and then shade in the 7 parts that we have. So notice if you start from that top model and we count, we have 1, 2, 3, 4, 5, 6, 7 parts. which is our numerator, and 7/5, and then our wholes are broken into 5 equal parts. So these models represent the fraction 7/5. So earlier we mentioned that a fraction is how many parts we have of a whole, or how many parts of a whole we have. And here you can see that when the numerator is greater than the denominator, the 7 is greater than the 5 and 7/5, that we have more parts than we can fit in just one whole. We have a name for fractions where the numerator is greater than the denominator, and they're called improper fractions, or sometimes they're called top-heavy fractions. You can see why they're called top-heavy fractions, because the top, the numerator, is greater than the denominator. Improper usually means it's not proper or not the right way, but that's not really what it means here. So it's just a name for the fraction. It just means that the numerator is greater than the denominator. So whenever the numerator is greater than the denominator in a fraction, which means that the fraction is going to be equivalent to more than one whole, we call that an improper fraction or a top-heavy fraction. So how does this relate to our learning target? Our learning target was I can use models to add and subtract fractions and mixed numbers. Well, we talked a lot about fractions now, and let's look at the connection between improper or top-heavy fractions, like 7/5 that we were just looking at, and mixed numbers. So to do that, I want to look at the model that we drew for 7/5, and I want to take each of the two models that we drew, the top model and the bottom model, which together equal 7/5, and I want to figure out what they equal or what they're equivalent to. So let's take that top model, and first I want to write the denominator. So how many equal parts is that top model divided into? That's going to be our denominator. And that's right, it's divided into 5 equal parts. And in that top model, how many of those 5 equal parts do we have? In that top model, we have 5 of those 5 equal parts. So that's equivalent to 5/5, which is the same thing as one whole. And if you notice, the whole was broken into 5 equal parts. We have all 5 of those parts, so we have the whole. We have one whole. We have the entire whole. So we have 5/5 or one whole. Now let's look at that bottom model and try to think about what fraction that's equivalent to. So first I'm going to think about what's the denominator, how many equal parts is that model divided into. And if you said that it's divided into 5 equal parts or broken into 5 equal parts, you're correct, and that means our denominator is 5. And how many of those 5 equal parts do we have in that bottom model? That's going to be our numerator. So 7/5 is equivalent to 5/5 plus 2/5. 7/5 is equivalent to 5/5 plus 2/5. And that may not surprise you, because you may already have learned that when you add two fractions with the same denominator, that you just add the numerators, the denominator stays the same. So we could also look at that as 5/5 plus 2/5 equals 7/5. 7/5 equals 5/5 plus 2/5 is the same thing as saying 5/5 plus 2/5 equals 7/5. But we could also say that 7/5 equals 1 plus 2/5, right? Because 5/5 and 1 are the same thing. So we could say that 7/5 equals 1 whole plus 2/5. As you can see on the bottom there, 7/5 equals 1 whole plus 2/5. And this is where the idea of a mixed number comes in. Notice we have a mix of a whole number, 1, and a fraction, 2/5. So when we say 7/5 equals 1 plus 2/5, we can also call that 1 and 2/5, which we can just write like that. So 1 and 2/5 is a mixed number. So if we put that all together, 7/5 is equivalent to 1 2/5. So the fraction 7/5 is equivalent to or the same as 1 2/5, which you can see here, right? 1 2/5, 1 whole and 2/5 more. So now let's start doing what we said we were going to do in our learning target, adding and subtracting fractions and mixed numbers. We're going to start with adding fractions. We're going to start with a simple example. So we have 1/4 plus 2/4. The denominator tells me that we're going to be dealing with a whole broken into 4 equal parts. And the numerators tell me that we're going to be starting with one of those 4 equal parts, and then we're going to be joining together, adding 2 more of those 4 equal parts. So now so far our model shows us that we have 1/4, one of those 4 equal parts, and now we have to add the 2/4, 2 more of the 4 equal parts. And now that we've done that, you can see that the model shows that we have 3/4. So 1/4 plus 2/4 equals 3/4. 1/4 plus 2/4 equals 3/4. So here's where it starts to get really fun. You can see that we're being asked to find the sum of 3/4 and 3/4. The denominator tells us that we're going to have a whole or wholes broken into how many equal parts? That's right, the whole is going to be broken into 4 equal parts. And so then we have that first 3/4, and I shaded in that first 3/4, but then the addition of another 3/4 tells us we have to join together or add 3 more parts in, and there's not room for 3 more parts. So guess what we're going to do? That's right, we're going to draw a second model broken into 4 equal parts, and now we can fit those additional 3/4, those additional 3 parts into our models. And first I want to show you what not to do, and there's a reason for this. Don't leave a blank space in that top model and just fill in the next 3/4 in the second model. Because although you are going to see the 6/4 there, if we want to write that as a mixed number, it's not going to really show that in the model. So let me show you what I mean now. So instead what you want to do is you want to fill in the first 3/4, 1, 2, 3. Then we go to add the next 3/4. We want to add 1/4, 2/4, 3/4 without leaving any blanks in that first model. Because when we do it that way, we can still express the sum as 6/4, but 4/4 plus 2/4, or we can express the sum as 1 and 2/4. So 3/4 plus 3/4 equals 6/4, which is equivalent to or equals 1 and 2/4. 1 and 2/4. So again, 3/4 plus 3/4 equals 1 and 2/4. So far we've used models to add fractions. Now let's start using them to subtract fractions. So the idea of subtraction is a little bit different because we're starting with something. Here we're starting with 5/6, and then we're going to take away 2/6. So we're starting with 5 parts of a 6-part whole. Then we're going to take away 2 of those parts. So the first thing I do is I draw a model showing what we're starting with. Again, we're starting with 5/6. We're starting with 5/6. And then to show that I'm taking away 2/6, I cross out 2 of the 6 parts. So that's taking away the 2/6. And notice that I started all the way on the right and crossed out 2 right next to each other. And that's going to become especially important when we work with subtracting mixed numbers. So Let's get in that habit right now when we're just subtracting fractions. So what's that leave us with? We had 5, 6, we crossed out 2 6. Look at the model. How many sixths are left? How many parts are left? And if you said 3 6, you're correct. So 5 6 minus 2 6 equals 3 sixths. So now let's get to the part of our learning target where it says I can use models to add mixed numbers. So here are two mixed numbers, 1 1/4 and 3 1/4, also called 1 1/4 and 3 1/4. And we're asked to add 1 1/4 and 3 1/4. This can be rewritten as 1 plus 1/4 plus 3 plus 1/4. Because, for example, 1 1/4 is the same thing as saying 1 plus 1/4. And then, since it doesn't matter what order we add the numbers in, we can add the 1 plus the 3 first, which gives us 4, and then add the remaining 1/4 and 1/4. So we could express that as 4 plus 1/4 plus 1/4. So the denominators in 1/4 and 1/4 tell me that our wholes are going to be broken into 4 equal parts. But I also notice that I have 4 wholes. So the first thing I'm going to do is shade in those 4 wholes from left to right. So now I've shaded in those 4 wholes, but I still have to add 1/4 and then add another 1/4. And so I have an extra model there. It's broken into 4 equal parts because the denominator in 1/4 and 1/4 is 4. And I'm going to go ahead and add the first 1/4. And there I've done it. And now I'm going to go ahead and add that second 1/4. And there I've gone ahead and done it. And so if we count that up, I see 1 whole, 2 wholes, 3 wholes, 4 wholes, and then what's the fraction in that last model? And 2/4. So this is 4 wholes and 2/4, or in other words, 4 and 2/4. So 1 1/4 plus 3 1/4 equals 4 2/4. And you may even be able to look at that and, already notice that if you added the 3 and 1, you'd get 4. If you added the 1/4 and 1/4, you'd get 2/4. You might be able to see the 4 and 2/4 there. But here's where the models become even more important when the mixed numbers we're adding get a little more challenging. So when we're adding mixed numbers like 2 4/5 plus 1 3/5, I'm going to go ahead and skip the way I broke apart those numbers earlier in the video. And first I'm going to draw models showing those 2 wholes and that 1 whole, the 2 wholes from 2 4/5 and the 1 whole from 1 3/5. And so there are those 3 wholes, and I have them shaded in to show that we have 3 wholes. Notice that I still broke them into 5 equal parts because the denominator in the fraction part of the mixed numbers, 4/5 and 3/5, is 5, and so that tells us we're dealing with wholes broken into 5 equal parts. So far we've counted for we've showed the 2 wholes and the 1 whole, and we still have to show the 4/5 plus the 3/5. So we still have to add in another 4/5 plus 3/5. So we're going to draw more models. I'm going to start with 1, see if it's enough, and if not, I can always draw an extra model. So right now these models still just show 3 wholes because I've just shaded in 3 wholes, even though I have a whole broken into 5 equal parts next to those 3 wholes. Nothing's shaded in, so it's not showing that we have anything. But we're trying to, again, add in those 4/5 and the 3/5. So let's first add in the 4/5. How many parts do you think we need to shade in to add in those 4/5? So we're going to shade in 4 more parts.
And we were able to fit that 4/5 in the model that we drew, but we still have to add in another 3/5. We haven't added that in yet, and I can see that I only have room for another 1/5. So I'm going to draw another model broken into 5 equal parts.
And like I said, we already shaded in those 4/5, and we need to shade in another 3/5. Now what I want you to do when you do that is don't leave any blanks. So when we add in the additional 3/5, I want you to start with the first blank and count those 3 parts: 1/5, 2/5, 3/5. So here I've done that. I added in those additional 3 parts or 3/5. And now count from left to right. Let's see how many holes we have. We have 1 hole, 2 holes, 3 holes, and then we have a 4th hole. So we have 4 holes. And that shows the 4 holes. That's the number that represents 4 holes. And then we also, all the way on the right, we have a fraction. So look at that 5-part hole and how many parts are shaded in all the way on the right. What fraction is that? That's right, it's 2/5. So we have 4 holes and another 2/5, which is the mixed number 4 and 2/5. So 2 and 4/5 plus 1 and 3/5 is 4 and 2/5. Notice it's not just 2 plus 1 is 3. So that's why the models are really important. And to make sure we shade in those fractional parts without leaving any blanks as we shade them in is also really important. So far we've used models to add fractions, we've used models to subtract fractions, and we've used models to add mixed numbers. We're going to be moving on to using models to subtract mixed numbers. I just wanted to point out something I added to the learning target, that all of these fractions and mixed numbers have common denominators. So in 4th grade, that's what we need to understand, is how to add and subtract fractions and mixed numbers with common denominators. We don't have to find the common denominators in 4th grade like we did in the last lesson to compare fractions. They already have common denominators. So just notice that as we move on to subtracting mixed numbers. Okay, so let's move on to subtracting mixed numbers with common denominators. We're going to start with a easier one, and then we're going to move on to a more difficult one. So we're starting with 4 and 2/3 minus 2 and 1/3. And you might even be able to see it just by looking at it at this point. 4 holes minus 2 holes is 2 holes. 2/3 minus 1/3 is 1/3. So you may be able to figure out that that's 2 and 1/3 just by looking at it. But we're going to use models to do it, and we're going to do that partly because it's going to get more complicated when something changes, and I'll show you what I mean by that in a little bit. But first, let's model it out. So remember, with subtraction, it's different than addition because we're starting with something and then we're going to take away, and we're starting with 4 and 2/3. So I wonder how many models I would need to model 4 and 2/3. Would 4 models be enough? I don't think so, because we also have a fractional part there. We have, or 2 fractional parts. We have 2/3, right? We have a fraction there. So we're going to need 5 models to model 4 and 2/3. So here's a trick question. What amount do these models show so far? And the answer to that trick question is 0, because nothing's shaded in, and the models, by shading them in, are supposed to show what we have. But one thing we do know from the models is that our denominator is going to be what in any fractional part or parts of our mixed number? Well, each hole's broken into 3 equal parts, so our denominator is going to be 3. So like I said, we're starting with 4 and 2/3. That means 4 holes plus another 2/3. So notice that we have 4 wholes with all their parts shaded in. That represents the 4 in 4 2/3. And then notice we have a 5th model with just 2 out of 3 parts shaded in. That represents the 2/3 in the mixed number 4 2/3. So this model, or these models together, show 4 2/3. And I want you to follow this strategy exactly like I show it when you do it, because it's really important, and especially it's going to be even more important when the subtraction problem gets harder. So we start with 4 2/3, and we're taking away 2 1/3. So we're taking away 2 wholes and then 1/3, or 1 part of a 3-part whole. When we take away the 2 wholes, we're going to cross them out from the left. And that means that's meant to represent that they're no longer there. So that's 4 2/3 minus 2 wholes. But now we have to take away another 1/3. And what I don't want you to do is cross out a 1/3 right next to the 2 wholes that you crossed out. I want you to cross out any fractional parts starting from the right-hand side like this, taking away 1/3. So again, we started with 4 2/3. We subtracted 2 1/3. We crossed out the 2 wholes on the left. And then for the 2 1/3, we already took care of the 2 wholes on the left. We have that 1/3 to cross out, and we did it from the right, starting with the first fractional unit on the right. And think about what that leaves us with. How many wholes do we still have? And what fraction do we still have? So we still have 2 wholes, and then the fractional unit is 1/3. So we have 2 plus 1/3, or 2 1/3. So 4 2/3 minus 2 1/3 equals 2 1/3. Now I want you to see what happens when we change just a little bit of our original problem, our original subtraction problem. So notice what we changed. We changed 4 2/3 to 4 1/3, and we changed 2 1/3 to 2 2/3. So we have a new problem, right? We're starting with a different amount and we're taking away a different amount. So now our problem is 4 1/3 minus 2 2/3. And I want you to see what even a small difference here makes. So still I know I'm starting with something. I'm starting with 4 wholes and another 1/3. So I know that I'm going to need 5 models to model that. So you can see I drew our 5 models. I broke them into 3 equal size parts each, because the denominator in the 1/3 in 4 1/3, and in the 2/3 and 2 2/3, the denominator is 3. That means our wholes are broken into 3 equal parts. Notice I have 4 wholes, and then I have another 3-part whole, but I only have 1 part of that, so that's 1/3. So that models 4 1/3. And now the next step in subtraction, once we've modeled what we're starting with, the 4 1/3, is start taking away the 2 2/3. But remember, we take away the wholes on the left, then we start taking away the fractional units on the right-hand side one by one without skipping any spaces. So first let's take away the 2 wholes on the left from 2 2/3. So there you can see we've done that. That leaves us with another 2 1/3. But we took the 2 wholes away. We still have to take 2 more thirds away. So think about what you would cross out next. So first you cross out 1/3 on the right, and then another 1/3 on the right. And notice I did that without skipping anything. I just went from the model all the way on the right, crossed out the only third that was there, the only 1/3 that was there, and then I went right down to the bottom of the next model and crossed out 1/3. Let's look at how much we have left. So we have 1 whole left, and then in that other model next to it to the right, how much do we have left? 2/3. So we have 1 plus 2/3 left, or in other words, 1 and 2/3, which is written this way. 1 and 2/3. So 4 and 1/3 minus 2 and 2/3 is 1 and 2/3. 1 and 2/3. So in a moment, I'm going to have you try 6 practice problems. But before I even ask you to do that, I want to remind you that for each one, I want you to work slowly and carefully. I want you to draw models, and I want you to use the same strategies that we just used to find the sum for addition problems or the difference for subtraction problems. So make sure that you clearly draw models and use the same strategies to find the answers to each problem. So the first problem in your practice problem is 5/6 minus 2/6. The second problem is 4/5 plus 3/5. The third problem is 1 and 1/4 plus 1 and 2/4. The fourth problem is 1 and 1/5 minus 4/5. The fifth problem is 3 and 4/6 plus 3 and 5/6. And the sixth problem is 3 and 1/8 minus 1 and 7/8. We'll come back and we'll work through each of them quickly, but I'm going to have you pause the video, go ahead, try these on your own, and then you could check them against the work that you see when you come back after you've tried them on your own. And then we'll get to the exit ticket after that. Go ahead and pause the video. Okay, so the first problem, 5/6 minus 2/6. You can see the denominators are 6, so I drew a hole broken into 6 equal parts. I shaded in the 5/6 because when we're subtracting, first we model what we're starting with, and now we just need to take away 2/6 to find the difference between 5/6 and 2/6. So then I crossed out the 2/6 that we're taking away, and that leaves us with how many parts out of our 6-part whole? It leaves us with 3/6. So 5/6 minus 2/6 equals 3/6. 5/6 minus 2/6 equals 3/6. Okay, problem number 2, 4/5 plus 3/5. You can see from the denominator, we're going to draw holes broken into 5 equal parts. When I model the 4/5 there on the left, we could fit it in one model, but we need to join together or add another 3/5. So notice the dots in the black. I was able to get one more fifth in the model on the left, and then I had to go ahead and draw another model, a 5-part model on the right, to get the other 2/5 for the 3/5. So when we add together 4/5 plus 3/5, we get 1 and 2/5. So 4/5 plus 3/5 equals 1 and 2/5. So practice problem number 3 was 1 and 1/4 plus 1 and 2/4. Notice in the model that we took the 2 holes, the hole from 1 and 1/4 and the hole from 1 and 2/4, and our first 2 models represent those 2 holes. So we have the hole on the left from 1 and 1/4, then the hole in the middle from 1 and 2/4. And now we still have to add in or join together the 1/4 and 2/4. So notice that on the right hand side, we shaded in the 1/4 from 1 and 1/4, and on the right hand side after that we shaded in the 2/4 from 1 and 2/4, and all together we got 2 and 3/4. So for practice problem number 4, we had 1 and 1/5 minus 4/5. So remember, when we're subtracting, the first thing we do is we model what we're starting with. So you can see here I've modeled 1 and 1/5. I knew that the holes would be broken into 5 equal parts because the denominators in the problem I was given are 5. So after modeling 1 and 1/5, we have to take away the 4/5 starting from the right. So you can see now we've done that. We took away the 4/5 starting on the right. You can count 1, 2, 3, 4 that we took away if you look at those X's in the models. And then we can see what we're left with in the model. We're left with 2/5. So 1 and 1/5 minus 4/5 equals 2/5. So for our practice problem number 5, 3 and 4 6 plus 3 and 5 6. Notice the first thing I did was take the 3 wholes from 3 and 4 6 and go ahead and model them on the left. You can see they're the same color as the 3 wholes in 3 and 4 6. Then I took the 3 wholes from 3 and 5 6 in black and I modeled those 3 wholes next to the first 3 wholes. So there I have 6 wholes altogether, and now I just need to add in the fractional parts of the mixed numbers. So the 4 6 from 3 and 4 6 and the 5 6 from 3 and 5 6. So notice I've now done that here. If you look at the model second from the right, I have the 4 6 from 3 and 4 6. And then right after that, without skipping any spaces, I keep going with the 5 6 from 3 and 5 6. So you can see those 5 black dots. And so now we're ready to count up everything that we have to find the sum of 3 and 4 6 and 3 and 5 6. So we have, let's count from the left. 1 whole, you can say it with me. Let's start over. 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, 7 wholes, and then we have a fractional unit, 3 6. So 7 wholes plus 3 6 is 7 and 3 6. So 3 and 4 6 plus 3 and 5 6 is 7 and 3 6. One thing I really want to encourage you to do is draw your models really neatly, carefully, and slowly. These were 6-part models, each one of them, and if I had not drawn them neatly and carefully filled them in, I would have been more likely to make a mistake. So draw them really neatly and carefully. And every time I drew a second model or a third model, I looked at the model I already drew to kind of line up the parts so that I would make sure that I had 6 equal parts in each of my models and that they were neat, that they were accurate and correct. And so I go slowly and carefully to make sure I don't make any careless mistakes. So our last practice problem was 3 and 1/8 minus 1 and 7/8. Again, we need to draw our models really carefully. I knew to draw 4 models broken into 8 equal parts because I'm starting with 3 and 1/8, so I know I'm going to need space for 3 wholes, but then I have an additional 1/8, so I know I'm going to need a 4th model for that. So now we've modeled 3 and 1/8, and now I need to take away 1 and 7/8. Remember, the whole, the 1 and 1 and 7/8, I'm going to take away from the left. Then the 7/8, the fraction part of the mixed number, I'm going to take away part by part 7 times from the right hand side and then see what I am left with. So you can see I started with 3 and 1/8, subtracting 1 and 7/8. I took away the 1 whole on the left, and then for the remaining 7/8 from 1 and 7/8 that I needed to take away, I crossed each 1/8 out from the right very carefully to make sure I crossed 7 of them out. And then you can see that leaves us with how many wholes? 1 whole. And how many eighths left? 2 eighths. So it leaves us with 1 and 2 eighths. So 3 and 1/8 minus 1 and 7/8 equals 1 and 2 eighths. Okay, so we're moving on to our exit ticket. I just want to remind you before I even read the problems that you need to go ahead and use models and the same strategies that we just used, the same way we did, to add and subtract fractions and mixed numbers with common denominators. Okay, so the first problem, number 1, 3/5 minus 1/5. Number 2, 5 6 plus 4 6. Number 3, 2 and 2 6 minus 1 and 5 6. Number 4, 1 and 3/5 plus 2 and 4/5. And number 5, 4 1/5 minus 2 3/5. So that's your exit ticket. Work slowly, carefully, draw your models very neatly, be very careful and precise when you're adding or subtracting whole numbers or fractional parts, and show me your best work. And one last time, our learning target for today was I can use models to add and subtract fractions and mixed numbers with common denominators.